Thanks for joining me today. This is going to be awesome. This is going to be awesome. Let me put this up here. I don't need that anymore. Here's my agenda for tonight. This, by the way, is GeoGebra notes. So I am an instructional technology consultant at the Hamilton County Education Service Center. And my math teachers have been absolutely clamoring for math-specific whiteboards to use in remote learning and instruction. So this is something I've been recommending to all the math teachers around here who want some sort of a whiteboard that they can use. So my goals for the night, the first thing is how can I use GeoGebra to create a surface that kind of spans between two curves, and those curves need to be written in parametric form. So we'll kind of talk about that a little bit, but we'll essentially create a curve, a surface between two parametric curves, which was the example I was working on when you just joined, and talk a little bit about why it works. Why does this formula that we have, this strange form that we're going to use, why does it work? And then we're going to apply this idea of creating a surface between two curves. We're going to apply this idea to create a surface of not a surface of revolution, but a surface built on, say, a parabola that has a given cross section, and we'll use a cross section of a square. But if you can get a square, you can get anything. And time permitting, we will export that solid for 3D printing, and we'll get that Stl file into a slicer, excuse me, so we can actually see how that works. So again, everything I've done here on these goals, all of these goals I have done with high school students, calculus students, non-AP. They were not advanced placement kids. These were calculus kids, and they used to do this the old-fashioned way before GeoGebra simplified the commands for creating surfaces. So first off, a surface. Let's talk about a surface for a second. So I'm going to switch my tabs, and so on my screen I have two parametric curves. This one up here at the top, and this one down here at the bottom. And what I will do is I'm going to go ahead and hide this gray plane, the XY plane. So I'm going to click on the gear icon in the upper right corner and click on the show plane. And so that is hidden. And sometimes my students used to kind of, this would make them feel a little funny because it was hard to keep track of their orientation. So I'll go back up to the gear icon and I'll show the grid, the XY grid. So it's a little bit easier to kind of keep your bearings when you're dealing in the three-dimensional space. So what I want to do is I want to create a surface that spans from one curve to the other. And the command for this, I mean, if there was going to be a command, let me zoom in a little bit. Perfect. Let me scroll up a little bit. So if there was going to be a command, and you probably can't see that very well either, so let me zoom back out. All right. So if there was going to be a command, it would start as a surface. So I want to create a surface that goes from, say, curve A to curve B. And it's kind of like mixing paint is my analogy. It's mixing paint, but we'll talk a little bit more about what this command does and how it works. So, so to create a surface between these two parametric curves, we go U times curve A, which is a function of t. And then I'm going to add kind of the complement of it, which is 1 minus u times b written as a function of t. So what I'm doing, and I'm going to put a comma in before I go on, I'm kind of mixing the two curves together, and I'm mixing them together linearly. And I'll illustrate this a little bit more in a second, but I'm going to finish off my curve. So my t variable goes from 0 to 2 pi, but my u variable only goes from 0 to 1. So in a way, what's happening is the u variable is kind of like the mixing variable, if you will. So the u variable is kind of mixing one curve into another curve linearly. And so this is the general this is kind of the general form. All right, so that's the general form. Surface, u times one curve plus 1 minus u times the other curve. So when u is 0, the surface is all B. And when u is 1, the surface is all A. Now let's see if we can look at this a little bit differently using the slider. So on my slider, my surface's name is C, and that is actually a function of two variables. And so it's actually, C is a function of T, and it's also a function of U. But I'm going to make a curve using that. So I'm going to go a curve command, and that's how I create a parametric curve. And it is, my curve is going to be C as a function of T. And in this case, it's going to be N. And then I'm going to toggle out of that, and I'm going to go, T goes from 0 to 2 pi. Now, this worked yesterday, man. This worked yesterday. We're going to see if this works. We'll find out. Okay, so let's see. If I drag my slider N, oh, yes. Yes. So as I drag my slider N, that's kind of what's happening with U. When N is 0, I'm all the way up there at one curve. But as N becomes 1, I move to the other curve. And so as U takes on every value between 0 and 1, it fills in that surface, that kind of a linear surface between the two curves. So that's a little bit of the math behind this, a little bit of the math of why this is working. This command works super well, but you need two parametric curves for the surface to stretch between. You need two parametric curves. And the command for surface isn't going to change. I'm zooming out the wrong direction. It's killing me, kids. Oh my gosh, I've zoomed in way too far. So my surface command looks like this. That's my surface command. And really the only thing that's going to change, typically the only thing that will change in the surface command are the limits of T. So T went from 0 to 2 pi because I'm dealing with a circular function. And maybe the function names might change. So instead of A of T and B of T, I might have another thing, like maybe the front of T and back of T, if you could, so I could name my functions. U will always go from 0 to 1. And it's always a U times one function and 1 minus U times another. So that's a little bit of like kind of getting started. So what I would like to do is I would like to just check on our agenda to make sure, have I done, oh my gosh, this is super zoomed in, quick, let's make this medium. Oh, that's a little better. I don't know if I'll be able to find it though. We're going to find out. There you go. So we created a surface between two curves. And I tried to explain why it works a little bit. I hope that made a little bit of sense to you. So what I would like to do is I'd like to apply this technique of creating a surface between parametric curves. I want to apply this, and I want to create a solid that has a parabola base and that has cross sections that are squares. That's what I would like to do. That is what I would like to do. So I'm going to go back. I'm going to go ahead and click on my GeoGebra thing right there. That's okay. I'll leave that because I won't need to come back to that. And let me go down here to, I'm going to use the 3D calculator. I know some of you who know me, you're probably going, what? He's not using Classic? I'm going to try to use the 3D calculator. More than anything, just because I'm angry tonight, but that's okay. Ready, here we go. So before I get started, I want to make my 3D graphics window on the right-hand side. I want to make this a little bit larger. I also want to hide the gray XY plane, and I want to replace it with a grid. So I do all of that stuff. The first things first, I'm going to go to the gear icon, and I want to make the whole drawing area larger to use. So I'm going to go to my settings. And then when I click on settings, if I just scroll down to the bottom, the clipping box is the size. I want my clipping box size to be large. So that just makes everything a little bit larger. And I'll close that up. And then I'm going to, I want to hide that gray plane, but then I want to go back here and I want to show my grid, because we talked about that. Sometimes kids have trouble without, they need a reference. They need something for reference. So if you take away that gray plane and don't give them anything else, they lose their reference. And so here's what I'd like to do. I'm going to go ahead and look down on this plane. So it's like we're graphing a function. And what I'm going to do is I'm going to actually kind of click on this and hold the shift key down at the same time so I can drag my plane this way. And so what I would like to do is I would like to graph a parabola that opens downwards and crosses the x-axis at, say, 2 and 8. But I don't want it to be too tall, so I might scale it by a factor of maybe a quarter or a half. But let's see how it looks. So I'm going to type in f of x equals, and I want it to open downward, so it's going to be negative, and I'll try 0.25 to see how this works right off the bat. And I want it to cross at 2, so I'm going to go x minus 2 as one factor, and we'll cross it at 8, so I'll go x minus 8 is another factor. Yeah, and I think the 0.25 for my scale factor might be a little bit small, so I'm going to go ahead and maybe make that 0.5. And that's reasonable. That's reasonable, because I don't want the cross sections to be overly tall. Now go ahead and press enter like that, and that's perfect. And so when I tip it back up, yes, that looks good. That looks good. That looks good. And so here's what I want to do next. So first off, I better kind of move this down. So I'm going to click on the plane, holding the shift key down, so I can kind of move my 3D plane down a little bit. And so what I want to do to give you this visualization, I want to build a square that is that has one vertex on the x-axis and that has a point on the function that also is another vertex, and the square will be perpendicular to the x-axis. And I'm looking at Jose's comment about, are there other compound functions that combine functions a and b linearly? Well, that's a good question. I don't know. I guess there's something to explore and find out. That's a good question. So here's what I'm going to do. What I want to do is I want to place a point. I only want the point to move back and forth between x equals 2 and x equals 8. And so a command for doing this is called the point command. And what I'm going to do is that the point command is going to place a point on an object. And the object is going to be a segment. And that segment is going to go from 2, 0 to 8, 0. And let me zoom in on this if I can. See if I take a guess on the zooming wheel every time. I take a guess and I'm getting it wrong. So what this command is doing, this command is taking a point and placing that point on this segment, and the segment stretches from 2, 0 to 8, 0. And when I press enter and I scroll back out, I take a guess every time. I guess wrong. So this point A will only go from 8 to 2. So instead of constructing the segment, I have that point, and I hope this doesn't mess me up because there's only 2 coordinates to it. We're going to find out. So maybe I should go like this. Maybe I should go comma 0, because it is 2, 0, 0, really. I should probably go 8, 0, 0. Let's see what happens. Yeah, okay, I feel better about that because I always forget I'm in 3D. So I need to have 3 coordinates. I need to have 3 coordinates when I'm in 3D. Okay, so let's create another point. We'll call this point B. So Alfonso, you could certainly do that. I just wanted to show you guys a different way to do it. But yeah, I could construct the segment from 2 to 8, and then I could have actually pasted the placed the point on that segment. So yes, I could have done that. I just shown it a little different way. But that's cool. And so my point B is going to have the same x coordinate as point A, and it's going to have the same the y coordinate will be f of x of A, and the z coordinate will be 0. And so now I have this point A and that point B that kind of moves in unison. And if I kind of like flip it up a little bit, we can see how those 2 points kind of move together. And so what I want to do next is I want to build a square where A and B are the bottom vertices and the square is perpendicular to the x-axis. So I'm going to use a polygon command. So I like, this is a habit I got into back with my students in calculus, actually years back, is we would use the commands because I tried to introduce them to some coding things as well. So actually, these commands, the point command and the segment command, are just functions, and they take different objects as inputs. So in a way, they're doing a little computer science. So this is a polygon, and A and B will be the 2 base vertices, and there will be 4 sides. Oh, I did put that in the wrong spot, didn't I? There will be 4 sides, but I don't want to lay down flat. I want it to be perpendicular to the x-axis. And I will hide the name of that puppy. All right. And so this is kind of what this is looking like here. This is kind of what this is looking like. That's a good visualization. That alone is a good visualization. That alone is worth the price of admission tonight. Only because, I mean, this is something really challenging for the kids to see. And so what I could do is I could take, I could click on point C, and I could show the trace of that point, and I could click on point D, and I could also show the trace of that point. And so now as I drag point A back and forth, and what's nice about the 3D app is as I turn this drawing screen around, the traces stay. But that is cool, man. I think that's cool. So here's what I'd like to do. I can't build a surface. I want to build the surfaces. I want to build the sides of this puppy is what I want to do. I want to put the sides on this thing. And so what I need to do is I don't want the traces. I need to actually think about what the base of my what the edges of this solid is going to be, and I need to turn those in. I need to use parametric equations to write them. So I'm going to go ahead and zoom in and out a little bit. If I zoom in and out, that erases the trace, and I'm going to turn the trace off for each of those points because I don't want the trace to show anymore. All right. And we need to, we actually need to write everything in parametric equations. So I could actually probably hide, this graph because I really don't need that graph. What I am going to do is I am going to write it in parametric form. And so down here in my input, thank you, sir. I do appreciate that. I think it's cool. I think it's cool. So the parametric equation is a curve, and my x coordinate is t, my y coordinate is f of t, and my z coordinate is 0, and t will go from 2 to 8. So that gives me my, I guessed correctly this time. I zoomed in a little bit. I guessed correctly. So that is my curve command. That's my curve command for that function. That's the back edge. I probably should name this. I'm going to name this something that is suggestive. So this is the bottom rear of my solid. So I'm going to call this BR equals. So BR is bottom rear. So I can remember that. And so BR is that bottom rear curve. And now, so I want to do the same thing, but now I want to do a curve that goes along the x-axis from 2 to 8. And again, it's the same thing. It's going to be a curve. And it's t, but the y-coordinate is 0 and the x-coordinate is 0. And t ranges from 2 to 8. And I want to give this a name. I should have given this a name at the beginning. This is going to be the bottom front. So BF equals. I wonder if I put that over there, if that's going to be better. Yeah, I don't know. So that is my, so I've got the back rear curve and I have the bottom rear curve and then the bottom front curve. And so I'm going to go ahead and press enter. Well, I thought I was going to press enter on that puppy. I did. There you go. So I pressed enter. And let's go ahead and let's get the curve that goes along the back, the top rear. So it goes from 2 up through point C and then down back to 8. So this is going to be top rear. That'll be called TR, and this is a curve. The x-coordinate is t. The y-coordinate of point C is f of t, but so is the z-coordinate. The z-coordinate is also f of t. And t ranges from 2 to 8. And I'll press enter. And so what we have is, oh, this is starting to look good, man. This is starting to look good. Oh, yeah. So we have one more edge that we need to place on there. We have one more edge that we need to place. And that's the edge that is that is the top front edge that goes through point D. So the top front edge is also a curve. The x-coordinate is t, but in this case, the y-coordinate is 0. And the z-coordinate is f of t. And again, t ranges from 2 to 8. And so this is fantastic, but there's stuff. I'm going to have to do some things here before I get much further, but this is absolutely awesome. This is going to be cool. And so I can move. I wonder if I'm going to try something. Animation on. Oh my gosh. Oh my. Ready? Oh, bing. This is nice, man. This is good. This is a nice visualization. From Tennessee, man. Hello from Tennessee. All right, I'm going to stop. Oh my gosh, I don't even know how the heck I stop it. I guess I had to go back up and find where my point A is. There it is. I found it. I will stop my point A from animating. All right, now let's build our surfaces. Let's build our surfaces. So our let's build the top, because the top is kind of going to be the coolest thing. The top will be the coolest thing. So the top goes from TR, the top R, to the top front, or top front to top R. It doesn't matter, top rear. So my command for this is a surface. And if you remember from when we started, it's U times, I'll go top front of T plus 1 minus U times the top rear of T oh, not times t, of t. T ranges from 0, no, that was a teacher technique, from 2 to 8. And u always goes from 0 to 1. Always. Oh, man, this is going to be awesome. Here's my command. Let me zoom in a little bit. Oh, I guessed wrong again. I can't believe I keep guessing wrong on that puppy. I'm going to type enter. So there's my surface command that gives you the top. That gives you the top of that surface. Or the top of the solid, excuse me. That is... Oh, man. Good morning, sir. Good morning. So this is, gosh darn, I guessed wrong again on my Zoom. I keep guessing wrong. I need to remember. Let's see. I just got to commit to memory which way I need to turn my wheel on my mouse to zoom in and out. I should probably put it on the wall. So that's the top edge. That's the top edge, or the top surface. So let's create the back surface. So that wraps around the back. And so that goes from the top rear, which is TR, to the bottom rear, which is BR. So our command is going to work the same way. It's going to be surface, U, and I can leave a space for multiplying. And so that is top rear of T plus 1 minus U, bottom rear of T. And T ranges from 2 to 8, and U always goes from 0 to 1. And I don't know why I use U. I don't know why I do that, man. I don't know. I just do. Let me go ahead and press return on that. This is nice, man. This is turning out good. This is a powerful visualization, man. This is super powerful for calculus kids. This is a hard thing for them to see. They talk you talk about it, you try to draw really bad pictures on your board, and it wouldn't take much time to do this. You do it one time, you have it forever. Because this is one of those solids that's always done. All right. So that's good so far. So let's do the bottom edge. Let's do not the bottom edge, the bottom surface. So the bottom surface goes from bottom front to bottom rear. So BF to BR. So surface U times bottom front of T plus 1 minus U times bottom rear of T. T ranges from 2 to 8, and U ranges from 0 to 1. If you just, Karen, if you right click, I'll show you to get that, Karen, how to get the trace feature up there. If I right click on a point, one of my options in that sub menu should be to show the trace. And so that will show the trace for you. And then to erase the trace, you just simply zoom in and out. I don't think shaking it up or down will do it. I think you actually need to zoom to erase your trace. And so I have, I've got all three sides. I've got all three sides rocking this now. And there's one more side left, one more side that is left. But this is looking good, man. This is looking, oh yeah. This is looking good. So let's do the front. So the front goes from bottom front, BF, to top front, TF. So again, this is the last surface command. So surface U times bottom front of T plus 1 minus U times top front of T. T goes from 2 to 8, And U will always go from 0 to 1. So that's the thing that's never going to change. And then let me go ahead and click on enter. It's not bad. This is not bad, not bad at all. Now, if you would like to get rid of, like, there are little level curves or lines in here. So like on the blue surface. So if you'd like to get rid of like those lines, if I go to the surfaces, the commands that I wrote in, if I go to those surfaces and I go to the 3 vertical dots on the right side of the entry line, I can go to the settings. And then under the settings, if I go to the style tab, this is where I can change the thickness of my line. So I can make my line have 0 thickness. And when I close that, so what you'll see then on the top, there are no more kind of level lines, if you will. And so let me do that one more time for the backside. So the backside was our second surface we created. So that was surface B. And so if I click on the 3 vertical dots and I go to the settings, and again, that was under the style tab. And I just, well, let me make sure I got there. There it is. The style tab, and it goes to 0. Sometimes I find myself clicking on things and my clicks don't quite click. So this is good, man. This is good. And I guess I should probably keep doing that. So let me go to this surface here, and I will clean up those lines. And let me go to that last surface here. I'll click on the surface D, which is our front. And I will hide, I will make those line thicknesses 0 as well. And then I'll close that puppy out. This is a nice visualization. This is going to be nice. So now when I can drag, the students can still see the square on the inside, but now they have a really, really nice, a nice look at what that shape looks like. I think the only thing that you could do to improve this experience for your students would be to try to 3D print this puppy. You know, let's back when my students used to do these in GeoGebra, and they used to have to do it the old-fashioned way. In other words, the surface commands were also like parametrics in 2 variables. This is an easy parametric. This idea of u times b of f and 1 minus u times t of f, that did not work back in the day. We had to do that for each coordinate, like the x coordinate, the y component, the z component. So, and my non-AP kids rock that stuff. So I would like to, what I would really like to do is I would like to take this solid and I would like to export it so I could 3D print. And there's some things that we need to do before we do that. So, because what will happen is if I just exported this, if I exported this to 3D print, it's going to take everything. So it's going to take my coordinate grid, my axes. It's going to take all these names. Like, see these names down here in the corner? It's going to take all those. And it's going to try to print everything that's in my picture. So what I really want to do is the first thing, I'm going to go up here to the gear icon, and I'm going to hide my axes. And then I'm going to go back to the gear icon, and I'm going to hide the grid. And then I haven't really gotten a really good way of like hiding the labels of everything for the surfaces in particular. So if I go to the settings, and I'm just going to uncheck the labels, and I'm going to keep clicking on these objects over here. until I get through all of them, because the labels, you have to hide the labels. And if you don't hide the labels, what's going to happen is those labels are going to be printed. And so anything that has a, anything that you put up here, the label is showing, because I was careless when I started and I did not turn my labeling off. I always forget to do that. Always forget to do that. But that's the last thing there. I think that's pretty good there. And there's some other things, like I don't want these points to show. So I'm going to hide those points, and I don't want that segment to show or the polygon to show. And my guess is the only stuff that is left for me to hide would be these 2 points. So if I right click on those points, they're auxiliary objects, so they don't show up in my list on the left. And if I go to the settings, I will click uncheck the show object. And likewise, I will right click on this point, go to its settings, and I will also hide that object. So now my solid is ready to be exported for 3D printing. And so this would be the last, I mean, if you have a visual of this, that probably gets to about 75% of the way for the kids. But if you could, man, if you could make this into something the kids could actually hold in their hands and look at it and study and feel it and touch it, that's going to get them the remaining 25% of the way there. So this is, I'm in my mind, we probably have the capability to do this. So let's give it a try, see what happens. So I'm going to export this picture as an STL file. And so to do my exporting, I'm going to go to the upper left-hand corner to the 3 horizontal lines, the pancake stack, if you will, the main menu. And if I scroll down a little bit, I want to download as. I want to download this as an STL file. So I will download that as an STL file. Now, so in the 3D printing, what will happen if I leave this, if I leave these numbers the way they are, the width, length, height. So this is going to be a 4 centimeters wide, 3 centimeters tall, or I'm sorry, 3 centimeters long and 3 centimeters high. This should not be a surprise to you, because the length, remember, f of x determines the length. So these things are both 3 centimeters. That should not be a surprise, because it is as tall as it is long. The width goes from 2 to 8. So that's okay. The scale is, so every centimeter is 1.5 units. So that makes sense. Now this thickness, if you leave that as 3.5, it's going to be almost cartoonishly thick. So I'm going to change it just for our purposes. It doesn't need to be 3.5 millimeters thick. I'm just going to make it 2. And for printing purposes, that would be okay. I'm not going to create a filled solid. I don't want to do that. I would probably set up my 3D printer to do the infill itself. And so boy, I'm worried if I download this, I don't know where the heck this is going to go. So I'm taking my chances here. And I'm going to export this as an STL file. And it got downloaded somewhere, man. I don't know where this goes. This is my work computer, and I never know where things go. I just click buttons, and I find myself hunting around for things forever. But what I do is I use an online slicer. This is called Slice Crafter. ICESL. And so I use this to, what this does is this turns this STL file into a G code for my printer. And so my 3D printer is I don't know if you'll see it. They probably won't see a picture there, but it's right over there to the right of me. So here's, let's see if we can, I want to load the STL file. This is where it gets scary, man. This is where it gets scary. On the click on load, I have no idea where this goes to. I'm going to go to my, well, it's in my downloads. Wait a minute. And today is the 13th, and is it 9:39 p.m.? It is. I'm going to take my chances. I think this might be it here. I think this might be it. I'm going to click on that. I'm going to click on open, and let's see what happens. Oh, there it is. So this is ready to be 3D printed. So I can now there's some, I noticed this little tail end at the other side. And so that seems to be kind of a little like a remnant of something going towards the x-axis of the origin. So I'm really not sure what that is because there was nothing there unless maybe I missed a label and I didn't hide a label all the way. But so I could export this to a G code and I could print that out, and it probably would not take too long to print, would be my guess. That would probably take me maybe about 4 hours to print on my printer. But man, if you do this, if you have a 3D printed solid and you have this, I think the kids are going to have a pretty good understanding of what this solid looks like and the mathematics behind either finding the volume of that solid or finding the surface area. Most likely they're going to be finding the volume of this one. So I'm so used to telling people, go ahead and unmute yourself and yell at me now if you have any questions, but you guys could unmute yourself all day. I would never hear you because you can only communicate with me in the chat. So if you have a question, if you want to put it in the chat, go ahead and plop it in the chat because I'd certainly like to try to answer your questions. There is a bit of a lag. So what I notice is that there's about a 10-second lag from when I say something or do something on my computer screen to when it shows up on YouTube. And I'm just wondering if there's also a similar lag back from you to me. So this could be an awkward conversation. There could be a 20-second lag back and forth, but we will see. But if you have any questions, pop them in the chat. You don't need to do, Alfonso. I probably need to get this. I should probably. I wonder if I can get the code to you guys. If I go to, let's see, let me go to, well, let me save it. Testing lag. Okay, hold on. So it's 9:43 and 36. I don't have seconds, but yeah, nicely done, Howard. Nicely done, man. So that's a square cross section, Karen. Yes, that would be a square cross section, and it actually would be relatively straightforward to turn this into an equilateral cross section because you only need 3 edges. The challenge is creating the parametric equations of the edges, and honestly, looking over all of the AP calculus exams. I created a book of all the problems that involved solids and areas, and most of them seem to be square cross sections. So, and the polygon is the regular well, so let me back that up, Karen. There really is only one polygon tool, and it's polygon. But because I put a 4 in there after my points, it kind of recognizes that, oh, you want a regular polygon that has 4 congruent sides. So that it's the polygon tool, but because I used an A, B, 4, it recognized that, oh, that's a square. So let me save this. Let me save this. I'll just share it. So this is a square cross section. It would be really, really nice, Tim, if they only had something else we could use to kind of get this stuff to people.
No, I agree. I can drop them the link. I'll go to your profile page and drop them the link in the chat.
Well, I was thinking of something else, but that's okay. Anyway, so here is a yeah, that'd be awesome if you want to drop that in the chat for me.
Will do.
Yeah. So you can, if you oh my gosh, did I zoom? I've zoomed in. So the Locust tool, the locus isn't really an object that you can connect things to. So it's almost like a ghost. So you can use the locus to kind of trace where the edges are. But what I like to do with the Locust tool is to, I want to get my kids to maybe make a prediction as to what it might look like, and then to give them a kind of a quick look at what it might be. And so that way, at least they kind of know where things should probably go. But the Locust tool, I can't connect things to the locus. So it wouldn't be a useful tool for construction. It's a useful tool, I think, for discovering patterns. Juan Carlos, good evening, sir. Good evening, or yeah, well, it's evening for me. And that is very, very fuzzy. I notice this thing is very, very fuzzy. But hopefully Tim can get it posted for you guys. But anyway, I
was gonna ask you quick, would you be able to make that one public from your profile? Just copy it easily because of the search index feature being rebuilt. You know what I mean?
Ooh, yes.
Please, I can get it there right away. Thank you, sir.
Mm-hmm. Oh, do I need to make it, wrong thing? Do I have to publish it?
Yes, yes, that. But once you publish it, it's automatically public, even though it gives you the spinning wheel.
We'll find out. Maybe, man. Maybe. Nope, I'm zooming out the wrong way. Oh my gosh, there it goes. There it goes.
That should
All
work.
right. Let me know if you can find it then. Well, so it's morning there, Juan Carlos. Well, it's past my bedtime. That's all I'll say. But that's all right. I got to get up. I'm doing another session tomorrow with some teachers in South Africa. So that's at 7 o'clock my time. So I'll get a couple hours of sleep. I'll be okay. Oh man. Oh, so you're like a antipodal points is what you are. You're like almost like if I drilled through the center of the earth, I might come out where you are.
Just posted the link in the chat.
Perfect. Thank you, sir. Thank you. So so if I went back over my agenda, let's see if I achieved my agenda for tonight. Let me go to my resources. And again, I did this in GeoGebra notes. And so I got to pop it out of my notes. And let's see. So did I meet? So We discussed about how to create a surface between two curves. We did that, and we tried to explain why it works a little bit. And then we applied that knowledge to creating a surface with a square cross section, which we did. That was this. Who knows where it is now? Oh my gosh, that's not it right there. So now I need to go back and probably share. I think I clicked off share, didn't I?
Yeah, accidentally. Just go ahead and reshare. Yeah.
Yep. That was the first thing we did, but I think I got off of my actual 3D solid. And then the last thing we did is we exported for 3D printing. So I'm going to put check marks on everything that we did. And then here's where we ended up as a 3D printing. And that would be cool. And like I said, I think that would probably take, looking at the size of that would probably take about 4 hours, maybe a bit more. But that would be super useful for kids to help with their understanding of these hard to visualize cross sections or solids and surfaces in GeoGebra. So I think, I don't know, guys. I don't know. I think that's all I got, kids. I think that is all I have. That's weird. I must not have saved the picture. All right, boys and girls, that's all I got for you. If you have any questions, I'll hang around here for a little bit in the chat. But I appreciate everyone coming and sticking around. So that would give you a equilateral triangle perpendicular to the x-axis. That's what that would do, Karen. Yes, yes, yes.
And Steve, since the live chat disappears when we edit the video to trim off the beginning part,
Yeah.
I'll put the link to that GeoGebra construction in the description so people can access it at any time.
That's a good idea. That's a good idea. All right, I'm gonna stop sharing, kids. I will stop sharing. Oh my goodness gracious. Oh my goodness. You're welcome, Karen. Thanks. You're welcome, guys. I appreciate that. Thanks for coming tonight. Thanks for hanging out. So, Howard, here, let me go back and share my screen with you again. I'm going to share my screen. I was using the one of the newer apps, but I will show you where to go. Oh, I know what you meant. I know, you're fine. So so in the 3D calculator, in the newer calculator, I don't need that. In the bottom left-hand corner where there's a keyboard icon, if you click on the keyboard icon, there is or are 3 horizontal dots towards the right-hand side. If you click on those 3 horizontal dots, this is where you can go to find a list of all your functions. My guess is that the polygon command would be under the geometry tools. So if I go to geometry and I uncollapse it, there are a boatload of tools, man, you have to scroll through. But if I get down here to polygon, that gives me the general kind of shape or the inputs. And if I go to show online help, this usually gives me a couple of really nice examples. So like examples where you could copy and paste these examples into a GeoGebra file and just observe what happens. So Howard, that's where you can find those commands. And if you also just search for GeoGebra commands, it'll probably get you to this wiki anyway. So. Okay, stop sharing. Oh, let's see. Karen, do you have any instructions on how to build those parametric surfaces? How does it, so, okay, so it's Karen's question is, I've probably got a couple of screencasts I could rustle up. And then Howard, your question, how does it know to do a regular four-sided shape? So in the, I'm gonna go back and share my screen again, dude. So it's magic, Howard. This is all, that's what it is. It's just magic. So in the polygon command, it either gets a list of points or it gets 2 points and a number. And so it's recognizing what it's getting as an input somewhere. So when it gets 2 points and a number, it's recognizing that this is a regular polygon is what it means. But when it gets a list of points, it's going to connect the points together. It tries to connect 2 points together, but when it gets the number, it recognizes, oh, polygon. In 3 dimensions, you need to give it a direction to be perpendicular to. So that's how that would work, I think. And magic. All right, boys and girls. I appreciate everyone showing up tonight, man. This has been a lot of fun. I'm glad I got to share it. We're doing this. Is this next week? I'm doing this next week too again, aren't I? Oh my gosh.
Man, you agreed to 2. I was like, thank you so much.
Man, what did I do? Next week we're doing statistics. Get stats teachers on here, man. We'll do some stats next week.
Absolutely.
But I'm thinking to myself, what did I do? What did I agree to do?
Well, thank you so much. A lot of people grateful for it, man. You're an amazing presenter. You have a lot to offer. So thank you so much for doing it. We really appreciate it.
You're welcome, man. You're welcome. I'm going to go to bed.
Go ahead. It's past your bed. Way past your bedtime.
Way past my bedtime. All right, man. I'm leaving the meeting. See you guys.
All right. Thank you, Steve. Thank you very much.